First off, you might wonder as to why we call this a geometric distribution. We call it geometric because it is tied or related to a geometric series, hence the name geometric distribution. So we have a sequence of Bernoulli trials. What is a Bernoulli trial? So at any given trial, you have either a 0 or 1. 1 is a success, 0 would be failure. And you conduct a series of trials, and the parameter for Bernoulli is P. In other words, the parameter for success is P. That is convention. P is always the probability of success. I am going to define X to be the number of failures before the first success. So the moment the first success happens, we're going to stop. Good, I am successful. So I failed forever, and then came one day and I succeeded. Good. And if that is the case, then X would be geometric P. X will have a geometric distribution with probability of P. That's the second one today. Let K be some integer. This has to be a discrete distribution because I can't fail 1.5 times or 1.75 times. Either I fail once or I succeed. So X is a discrete random variable. Before we go further, what is the support of X? 0 to 1. Zero to positive infinity. Why is that, Andre?
Because I guess theoretically you could fail and never actually succeed.
See, I could be a total loser and fail all the way to the end of my life, right? Limit approaches infinity, always failed. That would be my success, right? Okay, approaches infinity. My first funny joke ever. So we don't even need the distribution, but we can write directly using multiplication rule. In other words, you don't even have to memorize the formula. Do you want to take a guess as to what this distribution would look like? Right here, the formula. So P is the probability of success. I keep failing until my first success. And I want to know for X is equal to K. In other words, I failed K times and then I succeeded once. So if you use product rule, or not product rule, multiplication rule, you should know the answer. Well, if you don't see the pattern, let's say I did not fail at all. So the probability I would win or succeed in the very first trial will be P, right? It is 0 because X does not measure the number of successes, it measures the number of failures. Yes?
I thought we were using K. Just for clarity.
Okay, thank you. So if there is one failure, how many trials were there? 2, right? We need 2 trials. So I failed the first time. I succeeded the second time. Yes. If I had 2 failures, how many trials should I have? 3. So I failed twice, fail, fail, succeed. Yes. Q squared times P. If I failed 3 times, then I succeeded, so Q times Q times Q times P, Q cubed times P. Yes, if I generalize it for some K, what would it be?
It's with the K times P.
Q raised K times P. Good. Naturally, Q is a probability, P is a probability. They have to be between 0 and 1. Yes, it's a given. I don't even have to write that over here. So well, we want to verify the sum over all possible values of K, which in this case, 0 to infinity. The probability of X is equal to K must equal 1. If it does, then we have a valid PMF. So sum K equals 0 to infinity, Q raised K multiplied by P. Yes. P is a constant, can come out of the sum. K equals 0 to infinity, Q raised K. Yes, since Q is a probability, it can be only between 0 and 1. It would be a moot point for us to say it would equal to 0. It would also be a moot point that it would be equal to 1. Why? If I said Q is 0, then P is 1, right? I fail all the time with probability 1. If Q is 1, then P is 0, and I succeed all the time with probability 1. Yes?
I'll give you the other way around.
Oh, is it the other way around? Okay, the other way around. So, what's it? It's the other way around. So, you can also phrase the problem or rewrite the problem as the number of successes until first failure. It's the same thing, right? You just have to switch the probabilities. Symmetry. Since this is 1, or between 0 and 1, this series will converge. Do you agree? Calculus 2. Or is it 3? 2. That is an infinite series. We are trying to find an infinite sum. What is the infinite sum of a geometric series?
A sub 1 over 1
What?
A sub 1 over 1
A sub 1.
Yeah, or A sub 1 is, that's your first term in the series.
Okay, what is the first term in the series?
B.
B.
G.
1. 1. It's 1 plus P squared plus P cubed. So the first term.
Oh, because you pulled it, yeah.
Yeah. So it would be 1 over 1 minus Q, because the infinite sum of a geometric series is 1 over 1 minus A.
Let's assuming your first term.
I'm starting at 0. And A has to be between 0 and 1. Well, it doesn't seem like it is going to add to 1.
Yeah, it does.
How, Dennis? Enlighten us.
Q is 1 minus Q.
Q is 1 minus P.
1 minus Q is P. Q over P is 1.
Mind blowing. So P times 1 over 1 minus 1, 0, minus times minus P plus P, P over P, he gets 1. So sum of all the probabilities is 1. So what we have here is a valid PMF. Do we agree?
Yeah.
Okay, so the probability that Dr. G gets a student's name correct or correctly is 0.1092. What is the probability that it takes 16 tries to get the name right? So if I define X to be the number of times I failed to get the name right prior to succeeding, and once I succeed, I'm good. Even though that's not the case, you know, one time I get it, other time I don't. I could model this as geometric. What should the parameter be? Parameter is P. 0.1092. So if I walk in tomorrow, what is the probability that I'm going to get a student's name right in the very first try? Huh? 10.92%, right here. That's. Now, what are we trying to find? Well, 16 tries.
Because at the 16th, you get to right.
Ah, I see, thank you. 15 failures and then 1 success. So 0.1092 raised 15 multiplied by 0.8918. Oh, 0.8.
The 15 goes with 59.
What'd you say, Nathan?
15, so the 0.1092 is just that, no power. The other one, the 28 something or whatever, gets power 15.
I got the answer to be 0.0192.
So it's 0.8908 raised 15 multiplied by 0.1092. What is that?
0.0192.
It is 0.0192. And you may think that's only a 1% chance. He's never going to get the name right? He keeps failing. Well, intuitively, I'm looking for an exact probability, right? I'm asking what are the chances exactly this many failures and then you succeed. That is going to be less. But if I rephrase the question and I ask you, well, what is the probability it takes me at least 16 tries to get it right? That would make more sense, right? Given this chance, I expect at least 16 tries are likely to be a good probability, right?
Wait, are you saying that it takes you at least 16 tries to get it, so 16 or more, or are you trying to say within the first 16?
16 or more.
That's about 17.65%.
17.65%.
Then it takes 16 or more tries.
Okay, so it's probably then maybe 10 or more tries. I could do that. He's doing it using the calculator. You know, I'll show you how next time.
I'm just double checking to make sure that the Q is